We're back with part 3 of our shader tutorial series, and this particular lesson we're going to start getting into textures, which finally we've worked up to. So remember from the previous 2 lessons we learned the basics of CG shaders, and we were outputting colors, and we learned about blend modes, and we have good background now. So let's jump right in, and we're going to start displaying some textures on screen. And now we actually start to get into some of the more fun stuff with shaders. So the demo scene is pretty much just like what we were looking at in the last one. And if you haven't seen that, you're definitely going to want to go through lessons 1 and 2, because we're going to be building off of that with this one. And we just have a scene with a couple objects in here and playing in the background, just so we have some color there. So first thing we're going to do is open up our simple texture shader. And this shader right now, we'll go over each of the pieces here, so we can start to drill it into your head. So first thing is the shader tag, where we're displaying the name of the shader. And if you remember, when you're dealing with a material, the name will show up exactly as you type it, with all slashes ending up being a separate subsection. So we don't have any properties in here, so the properties block is empty. And in our subshader, we're putting ourselves in the geometry queue. So if remember, the geometry queue is rendered before the transparent queue. And if you also remember, we can add numbers to this to make our own queue. So if we wanted to be rendered immediately after geometry, we can do that, or immediately before, we can do that, or maybe you want to go way before. But for now, we're going to stick in the geometry queue. So we're just excluding a couple renderers here. PS3, Xbox 360, and Flash. Most of us won't be outputting to those, so we can skip those. We have our ARB Precision Him Fastest fragment option here, and then we have our vertex vert and our fragment frag programs. If you remember, these directly map to function names. So this is our vert program here, and frag is our frag program. And let's just remove that for the time being. So we have no uniforms. Well, now we have no uniforms, now that I just deleted that. And if you look at our vertex input, the 2 things we're going to have coming in here are the vertex coordinate itself, which, if you remember, is the actual position of each vertex. And we have text coordinate in here. And this is going to be the texture coordinate for the UV0. And that's how we're actually going to get the information that we need to be able to look up the pixel data in the texture. So we need to know exactly which pixels we want. So that's where that comes in. Right now in our fragment input, we're passing the position, and that's it, nothing else at the moment. So we've seen this all before in the vertex shader here. We'll just go over each one line by line. So we're declaring our fragment input struct, and we're passing in the position. And if you remember, we're multiplying by the unity matrix MVP. So this is the model view projection matrix, and that's all there is to it right now. In the fragment program, all we're doing is returning 1. So that's going to be the color white, fully opaque. So if we look at the scene, sure enough, that's what we have going on. So the first thing we need to do is we need to be able to get a texture in here. So the way we're going to do that is via properties. So we're going to follow Unity's naming conventions as always. So Unity calls it main text, which you've all seen before, I'm sure. And again, we want to do that so that our fallback shaders function. So it's really important to name things the same as Unity. If you don't, then your fallback shaders are going to not work the way you expect. So we'll just give this a name, main texture. It's of type 2D, and the default will just be white. So let's jump back over here and see what we got. Okay, so now we have, you can see that our texture appeared, and we have our normal little texture picker. So we'll stick the earth texture in there. So nothing's displaying yet, and that's because we have to do a little bit more work before we can actually display anything. So the first thing we need to do is we need to stick a uniform in here, and this is going to be of type sampler 2D. And we'll call it main text because it needs to match up with the name of our property. And if you remember, the uniforms are what allow us to pass data into the shader from our actual program. And Unity will take care of passing the main text in for us because we declared it as a property. Now you could also set this via code if you wanted to. Any of your uniforms, if you remember, you can set these all directly via code. So now that we have our main texture in here, we now have access to it. The next thing we need to do is figure out what we need to do in our fragment program, or in our vertex program. So the things that we need, we already have position, so we have that covered already. And the other piece of information we're going to need is the UV coordinates. We need to know exactly where in that texture we want to grab the pixels from. And we're going to want to pass that data into our fragment program. So if you remember, we have our fragment input struct here, and we're going to want to pass data from our vertex program to our fragment program, so we just have to add a new parameter into our fragment input struct. And for this particular case, we're going to do have2 and call it type text core 0. So we haven't gone into precision at all with regard to shaders. It's a really, really, really important topic, especially on mobile. And we'll start to touch on it here, but we'll go into more detail later. So what I mean when I say precision is choosing the types of your variables. And in a shader, we have a few different options. We have fixed, we have half, and we have float. And these options also they map directly over to your, if you have a vector of 2 or 3 or 4. These are all exactly the same. So you can use the same 3 types, and those 3 different precisions make a huge difference. This can't be understated enough. The precision that you use should match your types, and the amount of memory that your shader actually has to use is highly dependent on what you pick there. The different values are going to map to different things in your shader, and depending on what you're doing with them, you're going to want to choose the right type. So the fixed type is the smallest, and it's going to range from -2 to 2. So fixed is perfect for when you're dealing with colors, because if remember, your colors are usually in the range of 0 to 1, and the fragment program would clamp them to 0 to 1 anyway. So fixed is going to be what you want to use for colors. Half is the next size up, and these will go from -60K to 60K. And you want to use these for where you need a little bit more data. And then float is going to be your full float, whatever your particular operating system is. So this is going to be generally much larger values. So you want to use floats for things like positions and space, because positions could be vary drastically. So we'll go into a little bit more detail, and maybe even do some profiling so you can see the difference later. But for now, just keep that in the back of your head. You'll want to use the appropriate type. Okay, so for now we're going to keep this as a have-to in our UVs, and we're going to run with that. So we have our UV set up in our fragment input, and we're going to want to actually pass that on over. So if we jump over here, we can finally start adding to our vertex program here. So what we want to do is get the UV, which is in the text coordinate parameter. So there we have it. That's it. So now you'll notice we're passing in the UV of this particular vertex, and the shader will handle interpolating that value between the different verts for us. So we only have to set it once in the vertex input, and it'll just all be handled for us. So now let's get over here and let's remove this. We're not going to be returning a solid color. We want to actually look up the data in the texture and return that. So what we'd use is this text2d method, and the text2d method is going to take in a sampler 2d, which is our main text in this particular case, and then the UV coordinate, which is in our fragment inputs. We set that previously in our vert program. So now we are actually doing a texture lookup, and we're outputting that color of the texture. So if we jump over here, there we go. We have our first shader that's actually outputting texture data. And this is as fast a shader as you're going to be able to get with regard to having just the texture. Now, from our previous tutorials, remember we went over properties where we put a color property in here. So if you wanted to have stick a color property in here, you could of course do that and just multiply the color property by the text 2D lookup, and you'll get that tint color that you see in a lot of Unity shaders. Now, if you're not going to be using the tint color, it is absolutely optional, and you should be removing that from your shader. So this is where writing your own custom shaders gets to be awesome for improving your performance. Unity shaders are all completely designed for basically for being the most generic use case possible. They have all kinds of extra parameters that you may or may not need. So now that you're learning how to write your own shaders, you're going to be optimizing them just by default, because you're not going to be putting in extra things. Okay, so let's hop into Unity here, and something you've probably all seen is the tiling and offset parameters here. So if you see if we change the tiling parameter, you'll notice that nothing's changing. Our texture is not changing over there. And the reason for that is we're not taking that into account. So we're just directly taking the texture coordinate and getting that into our fragment program. So what we can do to remedy that situation is we can actually go ahead and have a look at the Unity CG Inc. So if you remember, we're including this Unity cg.cginc file, and this is the actual file here, and you can see it has a ton of stuff in here and all kinds of useful things for us, but we'll get into those when we start dealing with lighting later. The piece of information we're looking for now is actually going to be called transform text, and it's just a little define for us. And you'll see the explanation here above it, little comment, is transforms 2D UV by scale and bias property. Okay, that sounds exactly what we want. We want to take into account the scale and bias property. So let's go ahead over here and we'll use that little macro, and it takes in the texture coordinate first and then main text, the sampler after that. So let's jump back into Unity, and we get the fuchsia. Okay, so whenever you see this horrible purple color, it means something went wrong with your shader. Debugging shaders is not easy. So this Unity doesn't help you too much. If you look in the console, you see you get some crazy errors where it says material doesn't have texture property main text and some other things. And obviously if we look in the shader, we know it has that property, so that's not the right error. So if you actually select your texture, your shader here, you'll get some slightly better errors in here. And the one we're looking at here is you'll see it says basically we're missing this main text _st. Now if you remember, I told you that Unity has a lot of magic with regard to shaders, and showed you some of the magic before. So here's some more magic for you. Anytime you have a texture and you want to take into account the scale and bias, you can just stick in a float 4 and use your texture name and then _st. So now if we go back here, we'll see it fixes the error. The Unity won't clean the console for us, that's okay. But you can see over here that our shader is now clean, it's working. So let's just actually see if that's working. So now we can change the tiling and it does work. And if we change the offset, that works also. So that's all there is to it. So whenever you're going to deal with you're going to be dealing with textures, if you care about the scale and bias, just use transform text, and don't forget to add this extra main text _st. And if your texture was called something else, like for instance, if you had a second texture, you can just do that, and Unity will figure it out, and it'll perform its magic, and it'll fill that for you. Okay, so next up here, you can see we have this really ugly white background going on here, and we want to get rid of that. So if we look at our actual texture that we're playing with here, we have this earth texture, and it's actually it has transparency. And all this white here is actually transparent. So our texture in its current state is just outputting without taking into account any transparency. So let's go ahead and add transparency. Now if you remember, what we want to do is first stick ourselves in the transparent queue. So that's step one. So now we're in the transparent queue. Now whenever we're in the transparent queue, we want to turn Z-write off. And if you remember, the reason why is if Z-write's on, we're writing to the depth buffer, and if it's off, we're not. Transparent objects are generally not going to write to the Z buffer. That way their actual position in space doesn't occlude things behind it. So if we look over here, we still have nothing. And there's one more missing piece. If you remember from previous ones, we have not put our blend equation in yet. So we'll just do standard alpha blending, which is the source alpha and 1 minus source alpha. So now if we jump back in here, there we go. So we have created our first transparent texture, and we are outputting it in a shader here. All right, so just to illustrate and reiterate some of the blending issues that we saw in previous ones, I'm going to stick this in the geometry queue, and I'm just going to drop it to geometry -1, and so you'll see what happens now is it's actually in a queue that's behind the geometry. So it's getting rendered before the actual plane behind it. Now you can see clearly that these are in front of it, but it is getting rendered before now. We jump back into our shader over here, and if we turn Z-write on, you're going to see we get something a little funky here. We have this blending with the blue background. So even though it's in front, and it's clearly in front physically, it's actually blending with the blue color. And if we remember from previous tutorials, I'm just trying to drill this into your head. That's actually because the color in the frame buffer at when these objects are being rendered is actually blue. And the reason for that is because we're in the queue right before the plane. So before this plane is, if we turn off the plane, we can see before the plane is being rendered, the only color there is that, the background blue color. So that's just to reiterate the fact that the order that you render transparent objects is extremely important. So putting it back into our transparent queue, everything renders the way we'd expect. Now, if we look over here at this cube, for instance, we can see that we're rendering the faces that are pointed towards the camera, but there should be this backside as well. And for transparent objects, a lot of times you would still want to render that backside in there. So let's make a shader to do that. I'm going to open up this simple texture two-sided. Now this is exactly where we were just at. This is just all it's doing is passing in the UV and outputting the texture. So as this is right now, let's just put this on our material. It's identical. So this is exactly identical to what we were just working with. So how do we actually pull this off? And this is where we're going to introduce a new property called culling. So in our pass, we can add this cull property, and we can say, for example, cull front. And let's have a look at what that does. Okay, so if you look, it's actually rendering the backside. So it's rendering the far face, the faces that are furthest in there. So if we swap this to cull back, we can see it's back to where it was. So cull back is obviously the default when we're dealing with objects. Okay, so how are we going to pull this off? So the way we're going to need to do this is we're actually going to have to add a second pass to this shader. We're going to want to, in the first pass, do cull front, and that'll skip the front faces and it'll render the rear faces. And in the second pass, we're going to want to cull back. So let's duplicate this pass now. So this is our first foray into multiple passes. So it's literally the exact same shader, except in pass 1 we're culling the front, and in pass 2 we're culling the back. So let's see what we got. So now if we look at this cube over here, we can see it's rendering the way we'd expect. We can see the back faces and the front faces. And because of the order in which we did it, our pass was to first cull the front, we're actually rendering in the proper order here, so everything looks exactly the way you'd expect. So that is it for this tutorial. We now know how to make our own shaders with textures. We can blend, we can do transparent textures, we can handle transparency, and we'll start moving into even more detail and getting into more complex shaders in the next one. Thanks for watching.